In number four, we have a couple different differential equations, and we're going to use the separation of variables technique to find the general solution to each one. So we'll get started right away here. The first one, part A, what we're going to want to do is get the dx to the right-hand side. So what I'll do is I'll multiply each side by dx. Those dx's will cancel, and we wind up with dy is equal to 3y dx. We also need to get the y out of the right-hand side, and you can divide by 3y, although just dividing by y is fine as well, so I think I'll do that. And I'll represent the left-hand side as actually 1 over y times dy. The y's on the right cancel, and we're left with 3 dx. Now that we've separated the variables, what we need to do is we need to integrate each side. So we'll write the integral symbol, 1 over y dy, the integral symbol, and 3 dx. The next step is to actually find the antiderivative here, which is the natural log of the absolute value of y. That's the special one that we need to remember. And then we'll write 3x on the right-hand side. That's the antiderivative of 3. And then we have to add our constant all the way on the right. The last thing to do here is to solve this for y. So a natural log has a base of e. So I can write the absolute value of y is equal to e to the 3x plus c power. Also notice that we have an absolute value on the left-hand side, so we can change that into just y, but we need to put a plus or minus sign on the right-hand side. And that'll be equal to e plus or minus e to the 3x plus c. We can do one other thing here with this one, and that one other thing is to try to remove that constant out there from the exponent. It's still going to have to be an exponent, but a lot of times people will write this as e to the c power times e to the 3x power. Remember, your exponent rules, when you multiply like bases, you would add the exponents. So c plus 3x is the same as 3x plus c. The reason why you would do that is the e to the c power is just another constant. So it can actually help you solve it a little bit. But either one for right now is going to be fine. So you can circle or box in this one, or you can box or circle in the other one. They're just two different ways of writing the general solution. We're going to try to work with the same technique here on the right-hand side, and we're going to see if we can figure out what the general solution is, which is the equation that has a derivative of, for part B, x over y. And once again, to do that, what we want to do first is separate your variables. Be careful on the AP exam. If you don't separate your variables, you can't earn very many points, if any at all. So what we'll do here is we'll multiply by dx on each side. And if you want to, we can actually multiply by y on each side in the same step. The dx's will cancel on the left-hand side, leaving us with y dy. And on the right-hand side, the y's will cancel, leaving us with x dx. Then what we'll do is we'll find the integral of each side, or integrate each side. And we wind up with y squared over 2. So that's your power rule in reverse on the left-hand side. And then we'll wind up with, that's not supposed to be a z, that's supposed to be an equal sign. We'll wind up with x squared over 2 on the right-hand side, and then of course we need our constant of integration. All we need to do now is solve for y here, so we'll multiply each side by 2. So we'll have y squared is equal to x squared plus 2c. Some people will write this just as c again because 2 times c is a constant. It's going to be important for you to figure out where that c is, though, in these equations. So it's up to you where you want to put that constant. I'm just going to leave it here in the original antiderivative line right there, and we do need the 2c then in the next line. After that, what we'll do is we'll take the square root of each side. And remember, if we don't know if y is positive or negative, that when we take an even root, like a square root, we need to put that plus or minus sign out front. Everything underneath is going to be x squared plus 2c. And we have successfully now found the general solution, or an equation that has a derivative of x over y.